Okay, hello everybody. We're going to look at composition of functions. So the definition. Given two functions f and g, the composite function denoted by f little o of g is defined by, so f little o of g equals f of g of x. So here what you're doing is you're taking one function and putting it into the other. It's always in this order. Whatever function is to the right of a little o is inputted in the function to the left of a little o. Okay, and let's get the domains here. The domain is the set of all numbers in the domain of g such that g of x is in the domain of f. So the way to understand this is you're always going through that inputting function first. Any problems with g continue out throughout the whole problem of the composition. Okay, so let's take a look at an example. Okay, so here I have two functions. I have f of x equals 1 over x plus 2, and I have g of x equals 4 over x minus 1. So f is a rational function, it's a polynomial over a polynomial, and g is a rational function, it's a polynomial over a polynomial. So first thing I'm going to do is I'm going to find the domains of both of these functions. So the domain of f is a collection of x's such that x is not equal to minus 2. And the domain of g is a collection of x's such that x is not equal to 1. Got my two domains. Okay, so first I'm going to find f composed with g of x, and second I'm going to find its domain. Okay, so let's take a look at this problem. Okay, so first I'm going to make the composition function. So remember, you take whatever function is to the right of the little o and input it into the one to the left. So I'm going to start writing f until I get to the x value. Once I get to the x value, I'm going to replace it with 4 over x minus 1, putting one function into another. And composition of functions is all over the place. The computer that you're watching this on, that's a composition of functions. Then the computer, there's microchips, capacitors, inductors, all the rest of it, machines within machines. It's a really big idea. Okay, this is called a complex fraction, because you have fractions in fractions. So to simplify these, what you do is you multiply the top and bottom by the denominator of the mini fraction, or the little fraction. So for this case, my denominator is x minus 1. So I'll multiply that to the top and bottom. 4 over x minus 1 plus 2. Algebraically, this is legal. I'm just multiplying by 1 technically. And let's see, 1 here, be careful. If there is a number like 3 or 4 or whatever up here, you have to distribute. But here at top, I'm going to get x minus 1. This is going to get distributed over, and it multiplies here, it cancels out the x minus 1 at the bottom, so I'm up 4 plus 2, parenthesis, x minus 1, and then I'm going to clean it up a little bit. X minus 1 over 4 plus 2x minus 2, and collective like terms, you get 2x plus 2, and I'm going to go ahead and factor the bottom just to see if I can cancel out anything, but I can't. So here's my composition. So that was the first thing. Now let's talk about this guy's domain. Okay, so I put the simplified function here, and I rewrote the domains of each of these. So now I want to figure out what's the domain of f composed with g. Okay, so with this, you need to look at two things. First, it includes the domain of g. So any problems in here, any problems in g, continue out throughout the whole problem. So I know that x cannot be 1, because that would cause division by 0 in the inputting function, and you cannot do that. The other thing you have to look at is the actual composition itself. So when I look at this function, here I can see, okay, it also cannot be minus 1, because that would cause division by 0. This is the domain of the function. And the actual question is, well, what happened to this minus 2 business? The really thing with composition is you're always going through this inputting function first. So let's take a closer look at minus 1. Minus 1 is in the domain of g. If I plug in minus 1 into g, I wonder what we get out of this. It's 4 over minus 1, which is 4 over minus 2. which is minus 2. That's why this problem here in f doesn't go away. It's just that you have to go through g first. So that's why the minus 1 shows up. So minus 1 produces a value in g that screws up the denominator of f. Always remember, with composition, it is going to be whatever screws up the composition function and then whatever the domain is of the inputting function put together. Alright, that's composition of functions.